Over 90 billion United States dollars is the massive annual value generated by these endless grasslands. Why is this agricultural superpower facing a painful paradox today? The nation continues to feed global markets with volume. However, its greatest asset, the land, is deteriorating faster than ever before. At first glance, the soil seems stable, but in reality, it has lost more than 60% of its organic matter after decades of intense farming. But this is just the beginning. One can notice how the dry earth cracks under the pressure. Another 4 million hectares fall into severe degradation each year. It is visible how crops vanish from the fields, causing food security and economic standing to tremble. The problem is only gaining momentum. In desperation, the country chased every solution to save its soil. Yet all attempts failed until scientists discovered a clue in leftover sheep wool. The camera glides over the piles of fleece. This waste material turned the tide in the driest nation on Earth. 427 million hectares of agricultural land cover Australia. This territory is so vast it once seemed untouchable. For decades, it was the symbol of prosperity for the southern grasslands, where fields stretch endlessly and livestock feed the world. But beneath that greenery lies a different story. It is visible how the land hides a process of decay. Why are Australians alarmed by the state of their soil? At first glance, fields appear productive, but in reality, the land is deteriorating. In New South Wales, once the heart of agriculture, soil organic carbon levels dropped by an additional 3 1/10% in just 14 years, from 2006 to 2020. This means the soil is losing the ability to retain water and the nutrients that sustain microorganisms. But this is just the beginning. In Western Australia, the wind carries away the soil of a farming industry being stripped bare. At times, wind erosion removes up to 1 8/10 tons of soil per hectare per year. A layer that takes hundreds of years to form disappears after a few gusts. One can notice how fields are turning a dry, burnt red, the color of desertification. More than 6 million hectares are classified as being at extremely high risk of erosion. Another 3,200,000 hectares are collapsing from water-induced degradation. It gets more complex further on. In Queensland, households abandon plots that once fed families because the soil structure has crumbled. It can no longer hold enough moisture to sustain a growing season. 200,000 tons of waste wool accumulate on Australian farms every single year, turning storage areas and barns into massive stockpiles of unsold fiber. One can notice how the white heaps pile up, unwanted, unsellable, and almost useless to the modern market. Why has a sector that once generated export values exceeding 4 billion United States dollars collapsed so drastically? The answer is not immediately visible among the grazing merino sheep. Over the past 2 decades, global demand has declined relentlessly, shutting down factories and causing raw prices to plummet. But this is just the beginning of the struggle. Due to falling prices, thousands of farming households now find themselves without enough profit to even maintain their flocks. Forecasts for the period of 2024 to 2025 indicate that national production will drop to just 279 million kilograms. This figure is more than 12% lower than the previous year. It is visible how the industry contracts, leaving farmers with a surplus that has nowhere to go. At first glance, leaving natural fiber to rot seems like a simple solution, but in reality, wool takes 3 to 5 years to fully break down when exposed to the elements. Disposal is expensive, adding financial strain to an already struggling demographic. The process is only gaining momentum as the piles grow higher. Thus, the cycle of production slows down, waiting for a solution to the mounting waste. 3 to 5 years is the exact duration required for a pile of discarded wool to fully decompose under natural conditions. This slow breakdown creates massive accumulations of waste material in the shearing sheds, often viewed as a logistical burden. However, a new direction began to emerge from this apparent refuse, challenging traditional disposal methods. The focus shifted entirely toward using the fiber for environmental recovery. Why would scientists turn their attention to these seemingly useless mounds for the purpose of soil restoration? At first glance, covering vast agricultural fields with animal fiber appears to be an absurd solution for modern farming. But the answer lies in the microscopic architecture of the wool itself, which laboratory analysis proved to be an almost perfect structure for regeneration. Samples brought into the research facility revealed that each strand contains complex keratin scales, capable of holding 1.5 to 2 times their own dry weight in water. These fibers simultaneously create millions of tiny air pockets within the density of the Earth. Oxygen seeps through these voids into the ground, directly addressing a critical deficit found in Australia's severely depleted lands. But this is just the beginning. One can notice how the texture of the soil changes visually as moisture permeates the layers. Researchers in New South Wales spread a test layer of wool just a few centimeters thick over degraded plots to measure the reaction. The results arrived with surprising speed as the physical properties of the barrier took effect. Surface evaporation dropped by up to 35% compared to adjacent areas left exposed to the sun. It seems like a simple application of organic mulch, but in reality, wool maintains soil moisture for nearly twice as long as conventional materials. Microbial density, which had been previously decimated by years of intensive mechanical cultivation, surged by 30 to 50% after only a few months of observation. This biological shift kick-started a new cycle of recovery, allowing organic matter to form faster than before. And this is not the limit. Crops began to regain a firm foothold in the once barren earth as the roots found water. Farmers in Queensland applied the material to abandoned fields where the ground had cracked open from an inability to retain a single drop of rain. Despair turned to careful observation as the wool mulch prevented valuable topsoil from blowing away in the harsh wind. After just one dry season of application, the red dust transformed significantly. The land ceased to be a brittle surface, returning to a productive state. It is visible how the soil becomes friable and grippable again, ready for planting operations. Because raw wool tends to clump into thick mats that decompose too slowly, it cannot simply be dumped onto fields. Unprocessed fibers block water permeation into the depths, making treatment necessary. To unlock the full potential, engineers developed specific processing methods. Wool pellets represent a refined form where waste is mechanically ground and compressed into small, dense granules. These particles function like biological water batteries due to the unique behavior of the keratin structure. They expand significantly to absorb liquid when the soil is wet and contract to release it gradually as the ground begins to dry. This mechanism extends moisture retention by 25 to 40%. One can see the pellets swelling in the soil, easing the pressure of irrigation in arid environments. For long-term nourishment, manufacturers compost sheep wool with active microorganisms and additional organic matter. The keratin breaks down slowly in this mixture, transforming into a nutrient-rich feed. It releases a steady stream of nitrogen, sulfur, organic carbon, and trace minerals directly to the roots. As a result, the soil gains better heat retention capacity to withstand prolonged Australian heat waves without drying out. Microbial density rises again by 30 to 50%, allowing the land to regenerate on its own. In multiple test regions, crop yields increased by 12 to 18% without the introduction of a single gram of additional chemical fertilizer. The restored soil is now fully prepared for the next season of sustainable cultivation. 2,500 new jobs appeared in rural areas of the state of Victoria in 2024 alone. More than 40 startups focused on wool recycling emerged here in a single year. One can notice how small workshops open in places where the industry was previously stagnant. The impact extends beyond the revitalized fields, which function without requiring additional chemical fertilizers. But this is just the beginning. Why did a sector once mired in deep crisis suddenly rebound in a way no one anticipated? The market dynamics seem to point towards a complete decline of traditional processing. But as the soil began to improve, the fibers that once cost money to dispose of turned into raw materials that every local factory wants to acquire. At first glance, it seems like simple waste management, but in reality, it creates a material worth 3 times more than raw wool. The equipment gradually transforms discarded fibers into uniform, dense cylinders. Processing units produce nearly 900 kilograms of wool pellets from each ton of waste. The process is only gaining momentum. It is visible how waste becomes a product line worth millions of dollars, sustaining an entire new business ecosystem. The wool industry continues its recovery, turning a disposal problem into a stable revenue stream. 25 million sheep graze on the pastures of New Zealand, creating a vast biological resource across the strait. Why is this specific statistic critical for modern soil engineering? The nation observes Australian methods closely. This abundance allows local researchers to replicate the wool-based regeneration approach on a national scale. Results are emerging faster than expected. Farmers on coastal lands actively mix wool mulch into the sandy earth. The process aims to revitalize the ground structure for future planting. One can notice how the dry soil changes density after the fibers are introduced. This intervention helps the ground maintain moisture levels 20 to 30% longer than before. On the basalt fields of the North Island, researchers record the return of soil microorganisms just months later. This indicates the land is biologically recovering. But this is just the beginning. These positive signals quickly inspired the Kiwi business sector. Companies began looking for new applications. But innovation extends beyond farming in Wellington, where the startup Woolchemy turns waste wool into biopolymer granules. One can see how the material holds water with efficiency. It seems simple, but in reality, it opens a new technical avenue. In Marlborough, the famous wine region, farmers use wool as ground cover. This has reduced irrigation needs by up to 25% during prolonged dry months. Consequently, wool ceases to be merely a textile material. It is becoming a key agricultural tool. The sustainable process continues its development. It moves steadily toward wider adoption. 15 to 22% less nitrogen leaching is the specific result achieved on American fields. Why does the United States face a unique challenge with wool usage compared to global leaders? The local sheep industry operates at only a fraction of the scale found in Australia or New Zealand. Consequently, the core issue is not an overwhelming excess of raw material, but rather the urgent requirements of the farmers themselves who seek natural solutions. But this is just the beginning of the shift. Agricultural producers in California, Colorado, and Vermont have begun actively incorporating wool pellets into the earth. At first glance, this fibrous material seems unrelated to plant growth, but in reality, it takes on an unexpected role as an organic fertilizer filling a critical gap. Growers utilize it not to primarily address drought, as in Australia, but to establish a slow-release nitrogen source that organic crops typically lack to replace chemical additives. And something surprising happened during the monitoring phase. One can notice how the soil retains hydration significantly better after just 2 months of observation. Analyses confirmed that moisture levels stayed stable 18 to 25% longer compared with standard control fields. It gets more complex further on. In the United States, wool does not just improve the physical state of the soil, it helps protect the credibility of an entire agricultural sector. Because in a market where every fertilizer must prove its origin, purity, and sustainability, wool pellets have become a rare solution that satisfies all criteria. Therefore, it is no surprise that they have quickly become a new label of American organic agriculture. It is visible how many farms in California even print the phrase, "grown with wool pellets," directly on their produce packaging. This acts as a tangible promise of quality and transparency that consumers increasingly value. Hundreds of hectares. This is the scale where the transparency and ecological solutions consumers value move far beyond the story of wool fertilizers. At first glance, mowing grass beneath thousands of solar panels in Texas seems like a standard task, but using heavy machinery here is expensive and fraught with technical risks. But then, a new model emerged when people realized that sheep act as the ideal solution for this environment. Solar grazing was born from the simple fact that animals perform this work better than any machine. But this is just the beginning. Why are sheep superior to industrial mowers in such high-tech zones? The answer lies in the specific geometry and fragility of the infrastructure. Sheep clear low-growing vegetation effectively without damaging the complex wiring or the frames of the panels. One can notice how the flock moves through the rows, leaving the equipment untouched while the shade helps retain soil moisture. This protection allows grasses and soil microorganisms to recover, while manure adds natural nutrients to the earth. It looks outwardly simple to let sheep graze, but in reality, they serve as ecological maintenance workers restoring the soil structure. Many farms report reducing chemical fertilizers by up to 70% thanks to this organic cycle. Consequently, maintenance costs drop by half compared with traditional mechanical mowing. The United States energy sector is now partnering directly with sheep farmers, a collaboration that was once rare. In states such as Colorado and California, vegetation on solar grazing sites restores 2 to 3 times faster than on conventional projects. The process is only gaining momentum. From this synergy, a mutually beneficial model has taken shape where semi-arid desert ecosystems revive right beneath the shimmering panels. The number of solar grazing projects across the United States has tripled in just a few years. This rapid expansion has given rise to an entirely new service industry known as professional grazing crews. It gets more complex further on. These teams advise on designing solar farms to suit sheep movement patterns before construction even begins. They calculate vegetation density and account for breeding seasons to create precise weekly schedules for ecological maintenance. Agriculture, energy, and the environment merge here into a unified system. The model continues its development, ensuring a sustainable future for both the power grid and the planet. Billions of dollars spent on traditional water infrastructure often fail to match the efficiency of natural fibers. The results brought by sheep wool are not just Australia's success, but a signal for a planet that is gradually drying out. One can notice how the Sahel in Africa, where the Sahara expands by miles each year, could be revived by a material once considered waste. Why is this technology vital for the Middle East? The climate in that region is significantly drier than the parched lands of Arizona. Every drop of water there is critical for survival. It is visible how the wool allows soil to retain moisture for crops without billion-dollar irrigation systems. At first glance, this seems like a regional story, but in reality, it belongs to Australia, New Zealand, and the United States equally. But this is just the beginning. Solutions to the planet's biggest problems come from the smallest materials. Thus, a single strand of wool becomes a shield against global desertification